Alright, in this video what I'd like to do is continue working with the model problem that I presented in this section. The first part of this problem, we worked part A before in another video, which we showed you how to find a scatter plot, calculate the Pearson correlation coefficient, and discuss what the correlation coefficient told you about the strength of the bond or the relationship between the variables. In this video I'd like to work parts B through F, which this is all the basic regression stuff where you crunch the regression equation, interpret the slope and y-intercept, and then use the regression equation to make some predictions. So let's first do it in Minitab, and then we'll show you how to do it as well in the calculator. It's very similar procedures. In Minitab there's actually a couple of different ways to do it. Probably the easiest way to do it is to use the graphs feature and use the scatterplot option. So I'll show you that, and there's obviously a regression tab, so you can run the regression in there. It's called simple regression. So there's actually two locations to do it in Minitab. In the calculator, there's pretty much only one way to do it, and that's in the statistics menu. So let's do it in the Minitab software first. So I have the data in here. Remember, this is the question relating advertising with sales. So I have the 12 data points already typed in here. So the first way you could run the regression, so look at the question asks you, find the least squares regression equation. Okay, so that's going to be y equals mx plus b. Interpret the slope and y-intercept, and then it says to graph this regression equation within your scatter plot. Now, Minitab does that automatically for you. The TI calculator does not. You'll have to do that separately. But let's go ahead and create this, run this regression. So you go here to graphs and you select scatterplot. Now, I've already shown you how to use the simple scatterplot option, but a couple options later is this selection with regression. Notice it's got a line drawn through a little mini scatterplot here. So you select that thing, and it says, okay, what are you going to give me? Okay, well, the y variables, remember those are sales, and the x variables are advertising. Now notice there's a couple of choices up here. One is for the data, that's where we're at right now, data. But then there's the regression choice. Now this is for what kind of regression model that you want to perform. We are doing linear regression, so we want to leave that option. That's the default, it's already selected, so we're not going to change it. There are other types of regressions. There are many types. There's not just these three, as you could see. And the full version of Minitab, I believe, has upwards of 10 or so. So all you have to do is say OK. And what it does is it creates the scatter plot. Now this scatter plot should look familiar. It's the same one that I created in the prior video. And then notice it draws the line through it. Now if you take your mouse and hover over the line just right, what it does is it tells you the equation. So now I can't move my mouse. If I do, it'll take away this yellow box. But if you read, it says regression fit, comma. Then it says sales, which by the way, the word sales means y, don't forget. So that says y equals 28.6458 plus 13.8996 advertising. So what does that mean? That means y equals b plus mx. So it says y equals sales equals 28.6 approximately, plus let's call that 13.9 times advertising, which is x. So that's the regression equation. So I can come over here and just jot that down. So you could write y equals and the values here, we'll just approximate. We don't have to be perfect here with this. This is, let's call this 28.6 plus 13.9. Alright, so this is your sales is equal to 28.6 plus 13.9 times whatever the x is. So in other words, if we wanted to start making predictions, we could put values for x in here. within the range from 5.5. I think that's the lowest x value. 5.5. Yeah, it looks like 5.5 is the lowest x value. The highest x value looks to be 6.8. We could pick values between 5.5 and 6.8 for x. Pop them in here for x, multiply it by 13.9, and add on 28.6. And that would give me a predicted value for y somewhere on that red line. Now, obviously, the red line is the regression equation. It's not a perfect model. It doesn't capture all these data points, as you can see. It hits a few of them. It hits this one. This one's very close. This one, these two here are very close. And then it misses. Like this one, it misses by a lot. So that's probably the largest miss. And here's another miss right here from here to here. So the regression equation's not perfect, but it does a pretty decent job. So if we look at what this question asks us, find the least squares regression equation. All right, that's this thing right here. Let me highlight that thing in red. Interpret the slope and y-intercept in the context of this problem. All right, well, think about it. You could see if the x value here, let's pretend the x value is 0. If that was 0, then this value here would be 28.6. Now, this is in thousands of dollars. So in other words, this would be essentially what your sales would be if you didn't spend any advertising at all. So if the advertising is $0, your sales would be this. That must be like continuing or recurring revenue. Now, what happens if your value of x is say 6? All right, well, you put in 6 and it's going to give you this 112, obviously. But would that model give you exactly 112? Well, you have to take that 6 and pop it in here. What about a value that's not in this list? Like, say, 6.1 is not in there, right? See, it says 6.2, 6.3. 6.1 is not in here. It goes from 5.9. It does 6. I don't see 6.1 anywhere. So we could use this model right here to predict what the value would, what the sales would be if we spent 6.1 in for advertising costs. All right, so it says be sure to graph this regression equation within your Scatterplot and make sure your equation appears to best fit the data. All right, it does obviously. Minitab does this automatically for you. Now, as far as the interpretation of the slope, well, obviously, every time you spend another $1,000 on advertising, it's going to increase your sales by that amount. So obviously, this is just a multiplicative factor here. 13.9 is the rate of change, obviously, for every 1 that you spend on X. So this is, the slope, remember, just means a rate of change. All right, so what about this whole scenario, creating this regression equation now in the calculator? Well, it takes a little bit longer to do. It's not the end of the world, though. Now, I already have the data in here, I believe. So the data is already typed in here. So in the prior video, I showed you how to turn your diagnostics on. That has to still be true. Your diagnostics need to be on. These are already on. I haven't turned this calculator off, so it should be fine. So to run the regression, all you have to do is choose Stat and move over to Calculate. And then choose option 4, Linear Regression, AX plus B. Now, typically, notice how the calculator is blinking right here. It's blinking really slow because it's running so slow. But it's blinking because really it's waiting for you to tell it where the data is. The data is in list 1 and list 2. If your data is in list 1 and list 2, you don't have to tell the calculator where the data is. It knows to go there if you don't say anything. It's a built-in feature. So if I hit enter here, let it run the regression. And as you can see, let me move this out of the way over here. And I'll hover my mouse back on top of this regression equation again. Notice the values are right there, 28.6458. If you look over here at the B value in the calculator, notice it says 28.64575, very close, obviously, with rounding. And then 13.8996, and as you can see, that's the value of A in the regression coefficient there on the calculator. It also gives you the r-squared value. In Minitab, it shows it as a percentage. The r-squared value, remember, a nice interpretation of that is, how much better off are you using the regression line to make predictions rather than just finding the mean and using that as your predicted value. This says we're about 80%, 79.37, what have you. We're about 80% better off using the regression equation to make predictions than we are than just using the mean. So the calculator gives you the regression equation with its coefficients. It gives you the coefficient of determination, that's called r-squared. It also gives you the r value. Now, the Minitab software, it gives you the regression equation and the r-squared value, the coefficient of determination. If you wanted the correlation, you would have to use this correlation tab, and we showed you how to do that in an earlier video. Alright, so pretty basic. Now what happens if you want this, if you want to see this data running through, if you want to see that line running through the graph here, you have to actually tell the calculator to do that. So if you want to see the line going there, you hit the y equals button, and you give it the formula. The y prime here was 28.6. Plus 13.9 x. Now, I'm rounding these. Obviously, this 28.6 was, if you go over here and hover, it's 28.6458. I'm rounding to the nearest tenth for convenience, obviously. But, you have to physically type this in to y equals, and then you hit the graph button, and it'll draw the line through, and it's going to be the same picture as this. Alright, so there you have the same scenario, obviously, in both the calculator and in Minitab. Now, the only other thing I would say about Minitab is there's another way to do this whole procedure. Minitab does all this for you with the click of a few buttons. There's a menu called Regression. Now, remember, I got this Scatterplot and regression equation from the Graphs menu by picking Scatterplot and choosing the With Regression option. Well, actually, you could go to the regression scenario right here and run a simple regression. Okay, and it says, okay, what's your y's, right? Y's were sales, x's were advertising. What kind of a regression? It's a linear regression. There's some options here for confidence intervals. We don't need to worry about that. And graphs, I'm going to leave that alone for now. I'll show you how to do this in another video. So you say OK. Now this runs a full-blown analysis. And this includes some things that we haven't spoken about yet that we're going to learn later on in the course called analysis of variance. So this analysis of variance business up here, we're going to ignore that. That's later on in the course. But as you can see, here's the r-squared, the 79.38%. Here's the regression equation. Here's an interesting little piece of information. It tells you weird data values, data that fall far away. Remember I discussed that this value here looked a little far away from the regression line. It lets you know, hey, listen, when the sales were 100, there's a value that's pretty far away. That it's far away by about 2.28, and so it's it says a large residual, and of course it gives you this same graph here. So it really does a lot of stuff, as you can see. The regression menu gives you way more information than you would need at this moment. But later on in the course, we're going to, you'll understand what all this stuff is talking about when we finally cover one of the last chapters in the book, which is called The Analysis of Variance, or ANOVA. So we'll hit that stuff later on in the course. All right, so let's finish up these other questions here. So it says, predict the sales for an advertising amount of 6.1. All right, in other words, they're telling you what X is. So all I've got to do right there is put a 6.1 in there and work this out on a hand calculator. 28.6 plus 13.9 times 6.1 looks approximately 113.39. So that would be the predicted amount that this model gives me. All right, and the nice thing about the calculator is it'll do that for you. It's kind of amazing. The calculator, it does so many things. You can tell the calculator, give me a value. So if you hit second and trace, this first option here called value, you choose that, and it says, all right, what x equals what? If you say x equals 6.1, enter. There it is, 113.39. It's even showing you where it is in the graph. It's kind of remarkable. This little calculator does all this stuff. So it works this out for you, and that's in the second trace menu called calculate. All right, look at letter D. Is the predicted value in part D an interpolated or extrapolated value? And then it says explain. All right, well, remember the idea of interpolating versus extrapolating. That was discussed in the chapter. So an interpolated value, the problem is this model using the using this regression equation. It's fine as long as you're using it within the values that are given. Like the lowest value is 5.5 for the x's. The highest value is 6.8. So if you use this model for any number between 5.5 and 6.8, you can trust those results. That would be called an interpolated response. However, picking a number outside of it, what if you wanted to use this to predict what the sales would be if you decided to spend 8.5 on advertising? Well, 8.5 is outside the scope of these x's. We wouldn't trust that. That would be called a extrapolated value. All right, so is the predicted value in part D, well, this is actually not part D because I'm moving these things around, obviously. This is part C. Is this predicted value in part C, this value here, 113.39, is it interpolated or extrapolated? All right, well, it's interpolated because, and then it says explain, well, it's interpolated because the 6.1 right here that they asked us to predict is well within the 5.5 to 6.8. It's within the given values of x. All right, then what about parts E and F? Well, it's the same kinds of questions, but it says if you were told the sales are 125. Now remember, sales are y. So if you put 125 in there, you could back in by solving the equation. So in other words, take this equation right here and put 125 in for the y prime and solve that little Mickey Mouse equation for x by bringing the 28.6 over and dividing by 13.9. So you get that value for the sales, and then of course you could ask, respond to this letter F here, would you trust the model's prediction for the value you calculated in part F, why or why not? Well, that would be determined by, is the value that I got within the range of the x's or not? And I believe for that one it's not, but we would have to solve that and put that value into the equation. Take a few minutes, nothing crazy. All right, so again, just to rehash, we could use Minitab or we could use the calculator to crunch the regression equation. Both technology tools will graph the regression equation through the Scatterplot so you can see that it's actually working. Then we could use that regression equation to make our predictions. And remember, you only feel safe making predictions for interpolated values. In other words, values that are within the given range of the x's. 6.1 being one of those values. In another video, I'll show you the part G on how to create the residual plots. Both technology tools do it. It's just a matter of pulling it out. It takes a couple seconds. All right, if you have any questions on any of this,